This was a damaged, modified sine wave inverter's circuit board, which was from recycled, and has been repaired. A switch's socket is here on the board. A cooling fan socket is there. A socket of the output AC for the modified sine wave is right over there. The operational LED indicators are here. Those are the battery's positive and negative heavy-duty wires. Make sure to place the insulation pad on the back of each MOSFET, 6 of them. DIY made heatsink to be fixed on the back of the MOSFETs. Another one to be fixed on the back of 4 MOSFETs on the other side. Then secured them by the set of screws and flat plates. For the convenience, fixed it on the wood board, also connected a pair of the battery's cable and alligators on the board. A switch connected. And a pair of wires for the output AC. Connecting those wire with color matched from the black box, such as gray to gray, and red to red. Final the output is from the socket there on the black box. Regarding the black box, which consists of an inductor and a capacitor combined fixed inside box. Its details can be obtained by watching that video on my channel. In short, inside box has an inductor with its value of 360 mH and a capacitor of 3 μF. As shows from this diagram. The reason I do this content again is to clarify a couple of things to viewers on my channel regarding this type of converting. The larger inductor's value, the better result. In my case, it needs a 330 mH inductor at least. A pair of wires from the black box will be connected to the output of the modified sine wave inverter. The modified sine wave inverter's waveform must look like this, and is between 50 and 60 Hz. Those conditions are met, the sine wave can be converted from the modified one, and got from the output socket here. Final sine wave looks like this. It is not 100%, however it will be almost perfect, in practical situation. A multimeter's ampere position selected, to measure combined inverter's no-load current. Turn the switch on, then connecting the meter's probe to the battery's positive terminal. 0.62 ampere, or 620 milliamperes as indicated by the meter. It is good indication. Disconnected the battery. A mini oscilloscope has been connected to the output of the inverter combined. That thing is a voltage divider, connected between the inverter and the mini oscilloscope for safe operation. Connected the battery, then turn on the switch. The oscilloscope is indicating the inverter's output waveform for no load condition. It is a bit of distorted on the top, and at the bottom, otherwise it is pretty good. This is no load waveform. A bulb as a load is connected. Turn the switch on, then a bulb is lighting. Look at the waveform, it is very smooth, without distortion. Turn the switch off. Now, a bulb and a fan together as the load. Turn the switch on. The output waveform looks like this. It is not only smooth, but also very close to pure sine wave. It looks so nice. Turn the switch off. A multimeter's AC position selected to measure the load voltage. Turn the switch on. AC 241 volt has been showed from the meter, with a bulb and a fan running together, and the voltage is stable. That's how to convert the modified sine wave to sine wave, by adding a low filter set, such as a larger inductor and a capacitor together, to have it done in this way. Thank you for watching. Please like, share, comment, and subscribe if you have enjoyed the video. Your encouragement is my motivation.